Okay, finally I'm now ready to introduce you to my take on the finger joint jig. Commonly known as a box joint jig in the States. Here we call it a finger joint, but you all know what I'm talking about, and they all do the same job in the end. Now, as I've already made it, I don't want to go through the process of making it again unless enough people ask me, but it was quite a lengthy job, especially as there was no plans to follow, no real idea laid out anywhere for me to pick up on. It was all evolve as I build. So I think the best way to do it is to let you see me put it together, and I can explain as I'm putting it together what the bits are, what the bits do, and hopefully from that you'll be able to formulate roughly how to make one yourself. But if there's any questions afterwards about how things work, just message me, I'll be more than happy to tell you. Okay, so let's first just go through the parts that we've got. Okay, the first part is the base. It's got the two runners on it to go into the T-slots on your saw table. Just a flat piece of 18mm ply. As I've already fitted it and built it, you can see the cutout there for the saw. But it also illustrates here my saw blade guard, which is going to come through the back of the body of the jig, so I want to protect myself from that should it come too far. But I've also got socks incorporated in it that will stop it going that far, but should anything happen, I'm protected by that. Then we've got the two side walls, this one with the aperture for the thread to go through for the control. Both of them are put handle grips in. They fit on simply like so, and I can push it backwards and forwards through the blade. Then we've got the back plate. Now the back plate has the glide system on it. Top and bottom rails. Also here we have the calibration for it, which is just a steel rule, a 6-inch steel rule. The machine itself will do a total of 170mm in width and a depth of 35mm. How many timbers you're stacking is up to you. 4 is a comfortable number, depending on the thickness of them. We start from this point. This is a positive stop point that the carriage can't go, the shuttle can't go any further past than that. And then it travels this way, and we can read off the millimetre movement quite accurately. And that will sit there. Then we have the control stock. This is where the threaded bearings will sit against, so it cannot travel any further, and there's cogs set on the top of here. It's just again made out of 3/4 ply. As you can see, I've stacked many together to give me the stability and something solid to screw everything into, and that fastens simply to the body there, in line with the shuttle. And here we just have a sacrificial piece of pine, which just stops any tear out, and it's just held in with one screw and movable. Then we have the most important part of it. This is the shuttle, where the timber sits and what will move in order to give us the cuts exactly where we want them. In principle, the glides on the back plate run into the apertures at the top and bottom of the back of the shuttle. This is the stop point for the positive stop on the back plate. It's made up of, again, 3/4 18mm ply, and the back plate which runs in the glides is a 12mm ply with Formica surface to give us that slippy slide, and the fact that it fits into the glides perfectly. And I'll show you with this sample I've got here. Just a simple piece of Formica board. It's 10mm ply in the centre, not 12mm, but it works out 12mm with the Formica either side. And the glides just sit on like that, and they run very smoothly. There is no wobble, no movement at all once they're in place. So you get a nice, accurate travel. No need for bearings, no need for spring-loaded pressure or anything like that. once you've made it, as long as you cut your wood accurately, everything will keep exactly where you want it to be. Okay, so carrying on from that, I've then got here a exact 90-degree stop block that the timbers sit against, so that all the time when I put the timbers in, it's very simple, they're straight in against that. 3 T-bolts, these are for clamps, holding the wood down, and this one for holding the wood tight against there, against the 90-degree stop. And that just stops the chance of any wood moving slightly if it grips onto the base, which it can happen. Then we have 2 cogs, one with a T-nut in, which goes onto the thread, and the top, which actually controls it. Now, it doesn't matter in this jig what size teeth you've got or any calibrations to that. This is just a mechanical turning system, that's all. We're not bothered about counting the teeth, as you'll see later when we come to use it. A handle for that just to help, and a wooden magnifying lens. This sits on the top of the back just so that I can read the millimetre calibration accurately. A couple of clamps. This is the back wall clamp, and this one is for keeping the wood down. And then I just have a simple stop block which goes onto my table. This sits in the back of the table and into the T-slot, stopping the base sliding too far so the blade can't come out and get me. Okay, now let's go to the table saw and start the assembly, and I'll explain a little more about how things are working as we're doing that.